All right, so some quick announcements. The first one is that the assignment that was originally scheduled for last week that we didn't get time to do, that is now open and it will be due on the 10th, next Tuesday. It should be really short. It's just finding examples of shell scripts on GitHub and just linking to it and kind of reading through that a bit. So, for example, the FCF program that we went to, or that you all saw last. That's fine. The FCF program that you all saw last week, that is an example of one of these shell or command line programs. And so you will be trying to find another one online and just exploring that. So it should be really short. You don't actually have to program anything, and you have an entire 6 days to do that. In addition, KMP, if you are on the official computer science emailing list, sent out the committee applications for Perl Hacks. So Perl Hacks is a hackathon. If you're interested in potentially serving as a committee member, definitely check out the application there. Due dates are at some point, I don't remember when they are, but you could check the email for details and we'll send this out on campus. Now I'll hand it off to Noah to talk about Docker.
All right, cool. Thanks, Ajay.
Yeah.
All right, so I guess first, I'm just curious here, by raise of hands, who's heard of Docker? Okay, that's really good. That's actually fantastic. Okay, so you guys are somewhat familiar with it, at least by name. Let's just look it up. So what is Docker? According to Google, Docker is a set of platform as a service products that use OS-level virtualization to deliver software in packages called containers. Does anyone know what that means? Does anyone want to try and explain what that means? Okay, I didn't think so. I don't even fully understand what that means. And it's when you look things up, especially when you start dealing with newer technologies, you're going to get a lot of very technical jargon like this. And it is not the most helpful. So we'll try that one more time. I want you guys to think back to last week when we were trying to install Homebrew on some people's devices. And we had a lot of issues with people, specifically on Windows, because Ajay and I were on Mac. We just tested on Mac. But it wasn't working too well on Windows, so I hope you guys remember that. But you're going to hear this a lot. Has anyone encountered this yet? Again, just by show of hands, where you write something on one computer, it doesn't quite transfer to someone else's, or you'll have an issue running a program that you thought should just run fine. Okay, I guess not too much yet, but it is something that you will encounter later on. Because fundamentally, we have different machines. We have different environments. We've installed different programs. They're just different. We can't always assume that the same thing is going to hold for everyone's computer. And so oftentimes what you'll find is a program that runs fine on one person's machine won't so easily run on another person's. And that's because the programs we write on depend on a lot more than just the code of the program, right? A lot of times we think, okay, I wrote my Python script, I wrote my 110 assignment, that's it. It just runs, now it'll run anywhere. But as we found, last week, maybe in some of your other experiences, that doesn't always hold true. It depends on more than just the code. So it's a really early attendance check today. But what I want to get you guys thinking on is get into groups here, open up Gradescope, and try and answer this question. Talk to each other. What other external factors might a program depend on besides just its code? And yeah, I'm curious what you guys come up with. We'll call on a few people here. All right, sounds like discussion's sort of coming to an end here. Can anyone volunteer something that their group came up with, something that your program might rely on besides just the code? Yeah. Sorry?
System architecture.
System architecture. Okay, great. Yeah, and so what exactly, do you want to expand on that a little bit?
The only difference I know is ARM, x64.
Okay, great. That's pretty advanced stuff. So yeah, for those of you who didn't hear it, ARM, x64, it's basically like the actual way that binary is processed on your computer, but that's true. Yeah, different computers will process that in a different way. Anything else? Yeah, in the back. Yeah, great answer. External programs, and that's something that we find a lot. An antivirus is a great example. That can mess up our program. Other programs that you have running can just be interfering with what you try to run.
Preoccupied space and memory.
Preoccupied space and memory. Okay, yeah, good. Yeah, because other programs, right, could be using up space in our memory, so that goes sort of along with the antivirus thing. But yeah, we don't know exactly, where our code's going to run in memory. For one, if you're getting really low level. Yeah, great answers. Anything else? Yeah.
Different versions of programming languages.
Yes, that is a really key one right there. I'll repeat it for anyone who didn't hear it. Different versions of programming languages, and that's a great point because right? If you've looked at Python, right, everyone now uses Python 3, but just, half a decade ago is Python 2 that was a big thing, and there were breaking changes. If you try and run a Python 3 program in Python 2, it's not going to work. And same thing with Java, right? You might have a program that uses certain features of a newer set of Java that won't work on an older version that someone might have installed already. So yes, that's a really good one, and one that we're going to expand on here. Yeah.
I said incompatible file types.
Yes, incompatible file types, that's good. So yeah, what your machine might be able to work with normally and natively support might not be supported on another machine. Yeah, good points.
Dependencies you installed in order to run the program?
Yes, that is also a really good one. Dependencies you install, right? So very rarely do we write a program in pure isolation where we just write the code and we're only running our code. Oftentimes we'll require something external to our program, like if we want to make an API request somewhere, or just get user input. There's code that other people have written that we might depend on, and we can't always guarantee those will just exist on everyone's computers. So yeah, great. And we'll take one more. Yeah.
Like file system differences, like permissions and stuff.
Yeah, great. Permissions, that's a great tie into last class if you remember that. File permissions, right? We don't know if everyone's going to have the same one. Are they allowed to run programs on, well, hopefully they're allowed to run programs, but will they have read and write access to the same files that we have read and write access to? All very good points, and all problems that Docker aims to address. So yeah, these are just a couple. I think we hit most of these. So the platform, I don't know if anyone explicitly said that, but I think that was sort of said with everything else. The software version and environment variables. We didn't say that, but that's just another thing that could change between computers. And so one key piece of terminology here that I want you guys to understand is that all of these things together, basically everything on our machine when we run our programs is called our environment. And so that ties in with environment variables right here. These are just variables that we have in our environment that can change values. But you'll hear people refer to what environment are you working in. This is what they're asking, basically. What platform are you on? What software are you using? So keep that in mind when you hear that word. And so Docker at its core, like I said, aims to solve all these issues. And the key question is really just, what if we could somehow package up everything our program needs to run into a single thing? And that is fundamentally what Docker does. So if we could take everything that's in our environment and make it consistent across computers. So we could just take it, package it up, send it over to your computer, no matter what, I know it's going to work. And this ultimately ends up being a very, very powerful technology, right? Just on its surface, it seems like, oh, it's convenient, like it's cool. But what you'll end up finding is that it's really, people's machines vary a lot. And so the ability to take your program and guarantee it's going to work everywhere else is really, really important. And you'll see any big player in industry uses this on some level. In fact, Docker at its core, like the predecessor to it, this thing called C groups, was originally conceived at Google because they said, okay, we have all these computers, we just need to be able to write our programs, just have them fire up when we need them, take them down when we don't, and we don't want to have to deal with all this resetting up the same environment every time because it's very tedious. And so you'll see it there. And it's also used heavily in class. So I'm sure, raise of hands if you've seen this in 110 already. Yeah, I'm sure some of the curriculums use that. And you'll see it repeated a lot. Our class has already used it for an assignment, 211, 423, 530. It's everywhere. And that's because from an instructor's point of view too, the reason we had you do your first assignment there is because, once again, I didn't know. I didn't know if you're going to be on a Mac or Windows. So we need a way to predictably know that, okay, what I run on my computer, you're going to see in yours. And so that's what Docker allowed us to do. And so this whole process of taking your environment and essentially packaging it down, compressing it into one thing that you could just toss somewhere else, is called containerization. And this is something that you'll see if you ever look into Docker on your own, or you just learn more in general about this stuff. That's what it's called. And that's because we're essentially making something that contains everything our program needs to run successfully. And fundamentally, this process of containerization further breaks down into two steps. And that is creating an image and starting a running instance of the image, which is called a container. And I know that sounds a little weird right now. Why does containerization not just directly use a container? What's this image part? We'll get into that. But essentially, you want to think of it as an image is essentially a snapshot of your system. So from your environment, we see, okay, what are we on? Windows, Mac OS, Linux. What programs are we using? Python. What are our dependencies? And so if we could basically freeze our system in time. If we could freeze our system in time and basically take a picture of it, take a snapshot, that's what the image is. And so this is analogous to sort of like a frozen dinner. Like, it's not quite ready to eat, but it's like sort of just a perfectly preserved version of what you need. And then once you add a little heat to it, it'll be good. And then the container itself is a running instance of the image, and by extension, whatever program you've put in there. And so this is analogous to just sort of taking that frozen meal, heating it up, and now it's ready to go. So you've essentially activated it. So a container, in other words, is sort of like an active image. But an image itself doesn't run. It's just there. It's a thing. And the container is taking that image and running it. And I know this sounds it's very high-level hand-wavy right now. Once we actually start doing it in Docker, you'll see that there's basically one-to-one commands to do all this stuff. But sorry, I know that was a lot. Any questions so far? Any confusion? How do we feel with fundamentally what the purpose of Docker is? Can I see a thumbs up, thumbs middle, thumbs down? Okay, cool. Looking good. All right. So to create an image, this is the first step. Once we have the image, remember, we can go straight to a container with it. So creating an image is the hard part. But Docker, luckily, has made this process very easy with this thing called a Docker file. This is essentially just step-by-step instructions to create an image. And what you can essentially think of happening with the Docker file is you always just start with a base image. And a base image is like when you've just gotten a new computer and you just took it out of the box and now you're setting it up. So the base image is just some pre-installed, really basic stuff. When you get a computer out of the box, maybe nowadays they come with Python, but they didn't always, right? So you had to install Python. You have to install your dependencies. So essentially, if you were taking your program and putting it on a new computer, what are all the steps you're going to have to take to get it to run? And so this Docker file, we'll look at one in a second. It's very simple, just run in order from top to bottom. There's no conditionals, no ifs. It's just every single thing you do runs in order. And the terminology when you see Docker stuff is that an image is built with a Docker file. And to continue the analogy from before, if the image is a frozen meal, then the Docker file is just the recipe. So it's very step-by-step instructions, exactly what we have to do so that we predictably get the exact same frozen meal or image every time. And this is more as a reference. I'm not going to spend too much time on here, but these are really common Docker file instructions that we're going to use in a second here. And so if you want to take a look at this later on, very simple reference, I'll just go over all of them. So CMD, this is essentially, this marks, imagine when you type in your terminal like Python myprogram.py and you're starting it, that's essentially what CMD is. You just give it CMD and then you type that command, and this is what Docker is going to take and say, okay, this is the final thing that I want to run. This is essentially your program. Copy, so when we're building our image, right, it's very useful to think of this, like I said, as a brand new computer, and you have maybe your current computer to the side of it. So you think, okay, what do I have to do? I have to copy the files over. So this is what you have to do in Docker too. You need to copy the required files. There's N for setting environment variables, which not always going to use, but can be helpful. And there's from, which just specifies a base image, like starting point, like what new computer do I want to build off of, essentially. Run just runs any arbitrary command. And so you actually will find out this is a really common one and very powerful because it lets you modify the system in any way. You can just think of this as opening a terminal and just running a command in there. So anything you can do from the terminal, you can now do in a Docker file. And workdir, I don't know why they called it. I don't really like that. I just wish they called it like CD because that's effectively the equivalent in your terminal. If you were just CD, change directory into something, that's what workdir does. It just says, okay, make this our working directory in our Docker file. And then when I start like copying files over and stuff, it's going to all be relative to that directory. So yeah, like I said, this is a good reference, I think. These are really the most basic ones. You don't even need all of these to make a working Docker file. But these are like key ones that you're going to see repeatedly. So let's go ahead and create an image together. And sorry, when I say together, this isn't pushed out to you guys. This is more up here, but it's going to be a step-by-step so we can go through sort of what the process of creating a Docker file is and really get that down. Okay, cool. So if I come over, sorry, wrong way. Here we go. So let's go into our Comp 290 here. And this is, if pay close attention to this, because this is going to be similar to what your assignment's going to be, creating a Docker file, sort of understanding what's going on there. We'll go ahead and switch into, okay, so here we're in this file path here. And if I ls the files, we have example.py. So if I go ahead and run this, all right, just do Python example.py, we're going to get, no, sorry, let me, well, okay, this is actually not so bad. We can do this here. So if we run this script again. Okay, so we're actually going to see this. This is an error that wasn't supposed to happen, but it's okay. It says it was expecting the home. Wait, expecting.
I don't have something installed.
Oh shoot. Okay. Well,
Switch to yours.
Yeah. It was expecting something. It's not there. That's fine. So what we're going to want to do here is essentially create an environment, create a Docker file so that we can run this program in an environment that's consistent. So this is an example, I guess, of where code that I wrote that I just expected to work on Ajay's computer is actually not working here because for some reason I had, I guess, a slightly different version of Python. Ajay's was different, so that's not going to fly. So if I go ahead and we'll make a Docker file here, and in fact we'll actually open this up in VS Code.
One thing I will jump in here really quickly and mention is so just so that everyone understands what is going on here, that we have an example. This example.py is a program that we wrote. So you don't necessarily have to know what this does at the moment. It's just an example program that might be something that you wrote or someone else wrote, and we did not give this to you. This is just an example. For now, and this is in a folder that is just on my computer. So when we were changing to cd/ls, this is just into this lesson 3. That's just a folder that I have on my computer. And so if you're trying to, if you're trying to redirect or try to look for a certain file in here, you don't have it. So don't worry about that. This is just going to be showing an example of how to create a Docker file in this specific folder. And this last command right here, this code dot, I don't know if this will work automatically out of the box for you all. This is a specific command that actually opens Visual Studio Code at a specific file path. So you can see that when we were in this LS03 folder, we typed in code dot, and this opened up a VS Code window, just like this, at the file path that we selected. So since, and I'll quickly say here, see pwd, the working directory was this LS03 folder. So you know from the relative path lecture that this dot is kind of the placeholder, right, for the current working directory. So when we typed in code dot, we're simply saying we want to open a VS Code window at this particular file path, which is this right here. And so that's just to kind of place you all where what some of those commands were.
Thank you, Ajay. Yeah, I sped through those a little quickly. But actually, just to try and get this working here, I'm going to go ahead and comment that out. Like Ajay said, don't worry about this script. But let's try running it now. Okay, great. This is good. So this script, all it does, very simply, you might just be able to tell by looking at it. It takes your path variable and prints it out here. So if we look at this is Ajay's path variable, and it's very long. You'll see the longer you have your computer, the longer it tends to get. But I just wanted you guys to see that this is what is locally on his computer right now. So /user/Ajay, you'll see that in a lot of places. So let's go ahead and containerize this, right? So first we're going to have to make an image. And to do that, I said there's this thing called a Docker file. That's literally what it is. It is just a file. We're going to go ahead and create a new file here. Let's call it Docker file. And you'll see, it's supported by VS Code. You get a nice little icon there. This is it. So you just put it with your other files, and now we can write our instructions in here. So if we reference back here, These I just sorted alphabetically, but typically what you're going to see in a Docker file is the very first instruction is going to be from, because we have to say, okay, so what base are we using? If I'm thinking in the terms of like I'm getting a new computer, what new operating system, what new computer am I starting with? So we can go ahead and type this from directive here, and you see we have this nice autocomplete base image. So for the sake of this example, you'll see if you start looking this stuff up on your own, there's a ton of pre-made images. And one of the big points of Docker is that you can take anybody else's image and add on top of it. So it's like, I'm taking your computer with your program on it, and I'm going to modify it for my purposes. So I'm going to, from Ajay's image, let me add on. And we'll get into that later. It ties back in with some of what we'll see later on. But for the time being, I want you guys to just trust me that there is this thing called Python. There's this base image called Python that is, well, it shouldn't be that, that is provided by the Python people over at Docker. And what this allows us to do is basically just, instead of having to get a new computer, install Python all on its own, this just starts with Python pre-installed. So it's very nice. They took care of all that for us. So now we know we have Python. And so from there, we're going to want to set a working directory. We're going to want to, if we're just operating right now, by default, your working directory is just your root, which can get very messy. So we're going to want to go ahead and create one. We can call it whatever we want, but this is like, I'm starting a new project. I'm creating a folder, basically. And remember, for that one, the command is workdir. So workdir, and for this one, we'll just call it example app. And so essentially what I've done here is from Python, my new system with Python installed, I've opened up a terminal, and I've cd'd into /example app. So now that's my current working directory, but I have nothing in there. So what of these next commands does someone think I need to use to actually get my program over into my working directory? You can just shout it out. Copy, yes. Nice. And so we'll go ahead and use the copy directive. And we see it says source and destination. So what files do I want to copy, and where do I want to copy them to? And so remember, this first argument here is actually relative to where we currently are on our host machine, or basically on our personal machine. So that's source right here. So we're going to say, from where our Docker file is, our example.py is in the same directory, right? Which, if you remember from our command line lectures, is just // that means same directory. And now I could specify example.py. So this is saying, from my host system, from my system that currently has my program on it, this is the relative path relative to where the Docker file is located. And now I'll go ahead, and wherever I paste it in here, or wherever I type here, will be relative to my working directory, because this is essentially where I am on my new computer. So I'll go ahead here, and just for the sake of this, I'm just going to give it a period, which just means copy it over. If you remember the copy command, right? If you don't specify, if you just specify a folder to the copy command, it'll just take the exact file, copy it over to that folder. And period right here is shorthand for the folder that we're in. And in fact, we could do this long, like fully extended absolute path like that, right? They're the same thing. But for the sake of this example, I'll just give it shorthand, because that's how you'll often see it written when you read this. So remember, source, where is my Docker file relative to this, and then where we are relative to my working directory. And so after we have that, we basically have everything we need to run our program, right? We have the file over there. We have Python installed. So what's the final command here that I'm going to have to run to start my program? Yeah, exactly. So CMD. And CMD is sort of the special one that you'll see in Docker. It usually comes at the end because it's the last thing executed. But it just tells Docker, it says, okay, you've gone through all these steps to set up my image. Now, this last thing, this is like the entry point. This is what I want to run. This is fundamentally what this image is doing. So we'll just go ahead and we just pass it the exact command we want to run, Python example.py. And so with that, very basic, but we've got it. This is a perfectly valid Docker file. This tells us, okay, let's start an image. Our base image will be the Python one that's provided to the general public. We know it comes with Python pre-installed. we're going to cd into /example app. And a little caveat here is Workdir will also, if it doesn't exist already, Workdir will create that path as well. So it essentially is a 2-in-1. It makes that folder and then CDs into that folder. We want to copy over our example.py relative to our Docker file over into a location relative to Workdir. So this will just put it straight into example app. And then we want to start it. And that's it. So now that we have this, we know, remember the flow is Docker file, image, container. So we have our Docker file. Now the next step is to create our image. And so to do that, this is, you're going to see a lot of things that we do in this class. It's all from the command line. So this is no different.
I don't know if this was meant, I don't know if we've seen this in any of the previous lectures, but you will notice here that this section, in VS Code, you automatically have a terminal window, usually with the current working directory set to the same directory that's currently active. So if you were confused as to where this came from, this is basically the same as the terminal app, just nicely here so that you don't have to worry about getting that set up. Also, for the sake of a show of hands real quick, for the students who are currently in 110, have you seen this yet, the Python command? Okay, I think there were some nods and some stares, so I'll very briefly. This is just the Python command this is a program, just like any of the other programs that you've gone over. You just supply a file path of a Python file, and it runs that Python program. That's just to make sure that everyone understands what that is. Because there's Python twice. There's one at the top here and one down there, and I just want to make to highlight that these are two different things. One is a command to run Python. The other is the base.
Yeah, thanks for clarifying that. Yeah, they are very different things here. So let's go ahead, and we're going to build this. If you all should have Docker Desktop installed, which means that this should be accessible from your command line. If you just run Docker, you'll see, maybe I'll expand that up. So there's a lot of stuff here. I just ran it. I didn't give it any extra commands, so it's telling me everything I can do. It can be overwhelming at first, but really there's only a few key commands that you need. This first one to build the image is, conveniently enough, Docker build. And so this says, okay, from the Docker tools, I want to build an image. And then it expects by default, actually, if I just run Docker build, it should tell us what we need. Yeah. So Docker build x build. Docker build is just shorthand for that. I don't know. This is a really long version. It's entirely equivalent to just writing Docker build like I just did. It's just a convenience thing. Options and path, or URL, or nothing. So that's essentially saying we need to Docker build, we need to tell it where our Docker file is, because right now it has no idea. So because we're currently, if we look at our current directory, right, we're in /user/Ajay Gandecha, we're in LSO3, which is where our files are located. We can, once again, use our nice shorthand of just a period that says current directory, because, actually I'll go ahead and ls, right? We can see this is where our Docker file is in our current directory. So we're going to Docker build current directory. And so if I just run this right now, this is going to work, and we're going to get a valid image out. But there is this one other thing. With Docker, when you just build an image, by default, it gets a random ID, which can get really annoying to deal with. So we want to give it a nice human-readable name. And so they have this very convenient option, which, remember, these are command line arguments, right? These are things that we're passing to our program to run, little bits of extra data. If we do --tag and then specify some name, it'll take that name instead of giving us a random ID. So title it My Example App. And so I'm going to go ahead and run this. And you'll notice, so it's going to take a second. Where this all comes up, it's going to be very daunting at first. It's really weird what all this means. But essentially, this is just taking, the key thing here is that it's telling you what step it's on. So one of three, from, and then we see this whole URL here. Now remember, we had this from command right here. What this whole URL is actually an expanded version of just this shorthand Python that I have here. But it took that, expanded it out. So first it was downloading that, and then here we go, 2 of 3, Workdir, right? Example app, it just creates that directory and then switches to it. And then if we follow along, 3 of 3, it's copying the file over, and it completes that, and then a few last extraneous steps to just make it a valid image, and then we're done. And so that's one thing, I just want to really emphasize that it looks really, there's a lot going on here. But if you just look at these numbers, it's exactly following what we specified, just line after line. And so there is like a one-to-one between this and what's happening in your command line here. There's just a lot of extra data that Docker's providing us. And you see exporting the image, it's done. And now I'm going to go ahead and clear this. But now that image exists. And I'm going to go ahead and actually go into Docker Desktop here, because this is a really nice way of seeing what this is. And we see, after we built, we come to images, because that's what we just made, and we have it. My example app, what I just titled it, it's right there, created 57 seconds ago. And it's a little large, 1 gigabyte, kind of a lot, but that's there. And we can also see that if we just run Docker images, another command, there's a lot. This is another thing that happens when you use Docker for a while, but we see here at the top, my example app. And so then we have the image. The next step is just to run the image to start the container. So we want to actually see, okay, we've just made this whole container. We've put it into basically its own environment. We've packaged it all up. We've made it one thing. Now, how do we run that image? Very luckily, Docker has a nice run command for us. And so we just do Docker run. And remember, we titled our image my example app. We just provide that right here. And if we go ahead and run this, here we go. We've just gotten the output from our program. And it says your path variable is this. Now, I'm going to, if you look at that, that is very different from what Ajay just had on his machine. I'll go ahead and do that one as well. It might get a little messy here, but Python. So keep in mind, I'm in my local terminal now on Ajay's machine. I'm running this file on his device or on his machine directly, not through Docker. So you run that. These path variables are not the same, right? This one is much shorter, very basic stuff, and this is one homebrew, a lot of other stuff installed there. And so what we see here is that, right, it looks like our program just, ran the same way. We just ran it from the command line, but one was inside of Docker and one was just on the local machine. And because we did it in Docker, where our environment was different, where our operating system was different, because we specified this Python image here, which, a custom build of Python, nothing else, we see that it's a totally different thing. And that's just exemplified by the fact that the path variable is different. And so our environment is fundamentally detached from the one that's actually on the computer itself. Does that make sense to everyone? Can I get a quick show of thumbs? Like, do we understand why these path variables are different? Sorry. Cool. Okay. Awesome. I'll clear that out here so we have some space. And so, yeah, that's really, I guess I wanted to extend this a little bit more. But yeah, so we can go ahead and we'll add to this Docker file here. So I'll go back to example.py and I'll uncomment out this line. And actually, I'll just make it really basic so that it doesn't break again. I actually had to do this because my system was breaking when I did it. So now we're going to print out two environment variables. We're going to print out the path variable and the home variable. So if I run this again, and keep in mind I'm running this on Ajay's system, not in Docker. I just run Python example.py. And let's see here. Our path variable is this. Our home variable is this. And so home, you'll see, this doesn't exist on Windows systems, only on Mac or Linux. But it's just a little variable that points to your home user folder. And let's say for whatever reason, I'm making my Docker file and I want to override this home variable, right? So if we look through here, oh, nice, we have the env command that lets us do exactly that. We can set an environment variable. So let's go ahead. And so I can't insert it anywhere in here. I'm just going to go ahead and put it down here towards the end of my app. So I've set it up right from Python, changed working directories. We've copied our files over. But now we want to add env in. So if we look env key value, so if I just type home, that's the key, that's the path variable, or the environment variable, and I'll just say something like overridden home. So something like that. So now when we run this in the context of Docker, we'll hopefully get out that this is our home variable. And so I'll go ahead And so when we change our Docker file, this is another thing, right? Our Docker file only specifies at build time, what to do. But if I go ahead and change this Docker file, the image is not updated. The image that I made, it's still up here. It's still from 6 minutes ago now, right? It doesn't just change. So every time we make a change in our Docker file or we want to change our image, we have to rebuild it. And so it can get a little tedious. In fact, I'll go ahead here and just to clear everything up, I'll go ahead and delete my old image. That is not possible because there's a container running it. I will delete the container that's running it, and then I will delete the image. Okay, now we'll go ahead here and just go through our history, right? Same command as before, just docker build current directory, tag my example app. And I want you guys, this is gonna go a lot quicker here because what you're gonna see, I'll talk about it after, but just notice the speed of this build compared to the last one. And now it's done. So that was a lot quicker than our previous build. And I'm not even gonna go run this quite yet, but it points to a very interesting internal mechanic of how Docker works. And that is that every single one of these commands here essentially produces what's called a layer. And so you can think of this as a layered building approach where, right, remember we started with our base image. It's at the base because it's literally at the base of what we're building. And then for each one of these things, it's like a change that we're adding on in layers. So worker, that's one. Copy, that's another. Environment home, that's another. And then command doesn't quite create its own layer. It just says, okay, in this layer, what should I do? But that's the reason that this is just built so quickly. Because if you look at it, we did not change any of these layers. We only changed at this point forward. So it looked back, it said, oh, I have all these layers that are already done. Let me just go ahead and add on to that layer instead of rebuilding it from the ground up. And so that's another sort of thing that makes Docker really powerful is this concept of sort of reusability, right? Whereas before, maybe you thought, okay, let me just package all my things up. Oh, wait, I need to package this other app now. Oh, now I'm going to have to do it all over from scratch again. Docker says, well, if there's things in common, let's use those. Let's reuse as much as we can so we can minimize, how much more work we have to do, essentially. And this is starting to get into the weeds of sort of how Docker works, but that just keep in mind that layers are sort of, they're an integral part of it, and they're another reason why Docker is so powerful. And if I just go ahead and run this command or run this image one more time, Docker run my example app, we're going to see now, oh, our home variable is overridden home, so it worked. But that is essentially Docker from the perspective of using it to just run a program. And so you're going to see, especially in higher level classes, you might have to at some point deploy an application, at which point you're going to have to do this process where you make a Docker file, you put it all together, you make an image, and then send that image off somewhere to live. And if you do any personal projects too, it's a very, very powerful tool, very useful tool to use in your projects as well. So I want to go ahead and take a second. I want to make sure that I know that was a lot. I know there's a lot of me speaking at you guys. So I want to take a second and just get into groups, recap sort of the highlights of Docker. What are the important parts of Docker? What are the key takeaways? What are its strengths? Sort of what are its use cases? So we can just get into groups, talk for a couple minutes, nothing to submit here, but just so you all sort of understand what's going on with Docker. All right, everyone, if we could just bring it in here. Sorry, I know we just got a few more minutes here. Heard some good conversations. So can anyone just sort of offer a brief summary, something that your group took away from this, why Docker is important? Yeah, go ahead.
Standardization.
Standardization, great. Do you want to expand on that?
It's just like, you and I, so we're on the software engineering team.
Mm-hmm.
You have your own MacBook with your own packages. I have my own MacBook. Maybe I have a Windows computer, right? Whatever.
Yep.
Different platforms, different packages, different everything. But the Docker, it creates like a sort of container. It's like something common to both of us.
Yeah.
So instead of us trying to figure out all the bugs that's going to come up with our individual development, it's like, hey, we're all working on the same rough image. Yeah,
great point. Yeah, hopefully you guys were able to hear that. But the idea of standardization and having something shared between my computer and your machine, so that we don't have to do all this stuff like, oh, I have this program installed. Do you have it? A level of standardization there. Great point. Anybody else? Any sort of key, anything you thought interesting about Docker even? Just a summary, perhaps. I just want to make sure. Okay. Well, I'll trust then that you guys sort of got the gist of that. And a really good question came up here. That was, how do I know which base image to use if I'm using Docker in a personal project? And that is a really good question. I sort of glossed over that, right? I said, just take it on authority that this Python base image exists somewhere. And it does exist somewhere. And so if we actually follow that, this is a link, very helpfully provided by, but it's not actually a link, but VS Code has made it a link for me. So I click on that and open up this site. This is called Docker Hub, very much like GitHub. It is a place where people can make images and share them as much as they want. So the very helpful people over at Python, this is even a Docker official image, that's how you know it's good, said, okay, people need Python, let's just make an official Python one, and we'll upload it, and it even gives you the command if you want on your system, you just Docker pull Python. You don't even need to do that. Your Docker file's smart enough to know that if it doesn't exist, it'll pull it. But yeah, it's just called Python. And if we actually go to official images, there's a whole slew of things here. There's this thing called Nginx, which is very helpful for like web development. There's Alpine, which is just another like sort of basic version of an operating system that you can use. And so this is where you can go. This is where you can explore and you can look at these images and see, okay, what exactly comes with them. If we go back to Python, luckily it's been documented here. Come down here, there's a lot of versions. But how to use this image? Oh, so helpful. Create a Docker file in your Python app project from Python. There's this convention too where you can even very explicitly specify the version of the image you want with a colon. If we omit that, it just does the default Python 3, but we could have done this. And so they're very helpful. And they'd say, oh, here's Python 2 if you're from 10 years ago and need to use that. And then here's all your commands to like build stuff as well. So yeah, if you are interested in using this, and I would recommend even just exploring the hub a little bit, the Docker Hub, go to hub.docker.com and just mess around, see what images you can find, see what might be useful for you in a project. And yeah, I think Ajay had some stuff you wanted to take over with.
Yeah, so one thing I wanted to show real quick was a real world usage of this. So I kind of have gone, I've gone to this site quite a bit, which is the Excel site, mainly because I have spent a lot of hours building this up over the summer and before. But this particular site is currently live on the internet, and this is used by all of our CS students. And this site is also running inside of a Dockerized container. So all of the features that you see, all of the installation, everything is has Docker, or it's all inside of a container. I can also go to GitHub here because this is the source code, and you'll see that there is a Docker file here, and you can open this and you can kind of see the different. This is a much larger, as you can see, a much larger and maybe slightly more complicated Docker file. You can see here though that there is a front end and a back end. So these are two separate, this container has, as Noah was talking about, many different layers to it, where we build something called Node, and this is used by a lot of, if you're into web development and front end development, as they call it, and we'll be talking about that term more in the future. Node is something you'll hear of a lot. Node is, in fact, we talked about Homebrew and Brew last lecture, being a package manager for your command line. Node is and npm, which comes with Node, is kind of a package manager for JavaScript and a lot of web development tools. So you can see that this is an example where we have a starting image, which we can actually probably find here. If I try and search for this, I wonder if there'll be a. There we go. So you can see. Wow, 1 billion plus downloads. You can see this is a very, very common one. 8 million people pulled this just last week. So this is a very, this is a very common one, and that is all for our front end. You can see back end does use Python. So what we are talking about, so back end is like how the data and everything is stored and shared between all of the different computers in the site. So anything you see, like your news events or all of these organizations, are all saved somewhere in a database, and that's managed here. And so the reason why I wanted to show this is because This Docker file and having a Docker container for this site makes it very easy for two reasons. One, there are many people working on this site at once, and there are people who have Mac and Windows, and some are working on older computers, some are working on newer computers, and it would be very challenging if people are, sharing this code and all of their environments are very different. So by standardizing with Docker and opening it in Visual Studio Code and having the Docker file, everyone's able to work on it together. In addition, a cool thing is that when you actually go and deploy this and put it live on the internet, right, we have to take our code, package it up, and put it online, put it in the server, and we can upload the Docker container up there as well, and that ensures that our program can run on the server too. So not just on our computer, but on the server and everywhere. So this is a real world example. I can maybe link to this later, or you can just go to the Excel site and press on this fork on GitHub button right here, and this will bring you to this page, and you can check out the Docker file and kind of explore, and you might be able to see some and recognize some of the commands that we talked about today, like copy, workdir, run, etc. So that was a quick aside, but I just wanted to show that so that a tool that you are using right now at UNC is running with Docker. So.
Yeah. Thanks, Ajay. Yeah, it's a great point too, and I think that sort of reminds me something that when I was first learning Docker, it was very hard for me to wrap my head around this one idea that so the example we did, right? It was just a one-off program. We essentially just made a full Docker image and then we just ran it from the command line. It ran and then it was done. There was no it wasn't waiting on anything. There was no input to it. It just took it and ran. But Docker is it's for everything. It's for one-off programs. It's for these long-lived sort of program like a web server, something that's waiting for people to connect to it. It works for anything because it's not designed for a single use case. It is fundamentally just a way of transporting a whole environment, making sure a program can run wherever. So any program that you can make on your computer, you can leverage Docker to then just make it work more easily on other people's computers. But it really is very powerful in that sense too, that it can be used for anything. And any program you write, I'll say that. Any program you write, you can use Docker for in some way. And you'll even see that in sort of to the point earlier about standardization in some higher level classes. There's these things called dev containers, which is a very specific use case of Docker. But the idea was okay, so Docker is really good for when we want to deploy our apps, but what about when we're working on them, right? We don't even know that everyone has the same machine when we're working on them. Is there a way that we can standardize that? And people are oh yeah, we can use Docker, just make sure everyone has the same environment, and then they're essentially working inside of that Docker container, making changes in there on your computer, so then even during development time, everyone has the same environment. So very versatile tool, used for just about anything. If you want to do a Minecraft server, there's a Docker container for that you can just download and start, or an image that you can start as a container. But yeah, very, very versatile. I would really encourage looking into it more. Personally, I'm a big fan of it, in case you couldn't tell. But it's really just very interesting, something to get comfortable with, I think, because more and more I see it too, where people just be download the Docker image for this and use it. And it can be a little confusing if you aren't quite sure how to do that. So really, really a practical tool, very powerful tool, something you'll probably use, if you're in CS for the rest of your life at some point. So yeah, I'll end with that there. I hope you guys learned something about Docker. I hope you understand why it's important. There will be an assignment coming out. Sorry, it's not quite out right now, but some basic stuff so you guys really understand the Docker file, the ideas of Docker. But yeah, I hope you guys enjoyed that. I hope you guys learned something.
Quick thing I will mention before we close with the assignment. So again, there was that short exercise kind of relating on the related to the last lecture, which is out on Gradescope. In addition, it's not out yet because I have to find one link and paste it into the website before I update the site. But there will also be 2 videos. I think one is another 100 seconds video. It'll be Git in 100 seconds. Also, a little bit of a side note here with these 100 seconds video. It's kind of interesting after spending some time learning something to revisit them, because you probably hopefully you watched the Docker in 100 seconds video before this class, and it probably went by really fast and you probably understood about maybe half of what was said. But now that you've finished this lecture, try listening to it again. try listening to it again, because it's something where you'll realize you'll hear a lot of the words like images and containers and layers, and kind of watching it both before and afterwards is something that we recommend, even though it's not required, just because it'll help to reinforce the concepts that you're learning. So there's one Git in 100 seconds video. Also, Chris Jordan, who I don't know if any of you had for Comp 110 or maybe last semester, and he's been here as well. He recorded a video for the topic we're going to be talking about next week. So we're going to link to that as well. And he's done a good job explaining it and drawing diagrams. So there's those 2 videos, and then there'll be some supplemental resources if you'd like to read a little bit ahead. We'll post that. But that's all I have. So.
Yeah, thanks everyone. And if anyone needs help, I don't know if Jay will stick around. I'll be here for a little bit after, so just come on up.
Yes.
Talk to office hours.